Okay, let's look at the problem of price discriminations. Some beef pies is Townsville-based firms that sells beef pies in two cities only, Cairns and Townsville. So assume that the marginal cost is 0. So demand in Cairns is given by Q is equal to 2 minus PC. And in Townsville, Q is equal to 2 minus 2PT. Right, okay, so suppose some can charge different prices in each of the two markets. What will the price be and the profits? Okay, this is called third degree price discriminations. Okay, let's look at Cairns first. Okay, so our task is to determine what price I should charge in Cairns market and what quantity I should sell there. Alright, so we know that MC is equal to 0. Then our next step is to figure out what is MR and equate MR equal to MC so as to maximize the profit, right? Okay, MR, so to get MR, to obtain the marginal revenue, let's look at total revenue. Total revenue is P times Q. We know the demand is Q is equal to 2 minus PC. So let's get the inverse demand function. So move this term this size, this term this size. We get P is equal to, I'm going to drop the subscript C. P is equal to 2 minus Q. So it's equal to 2 minus Q times Q. So it's equal to 2Q minus Q squared. So marginal revenue differentiate total revenue with respect to quantity. So we get 2 minus 2Q. Equate this to MC, which is 0. This implies that 2Q is equal to 2 or Q is equal to 1. Okay, so plugging this Q equals 1 into the inverse demand function, we get the price. 2 minus Q is 2 minus 1 is equal to 1. Okay, so that's the price and quantity in Cairns market. The profits, total revenue minus total cost for the firm. Total revenue is equal to price times quantity minus total cost. Price is equal to 1, quantity is equal to 1, cost, marginal cost 0, and there's no fixed cost. So it's 0, so it's 1. Alright, let's Cairns. Townsville, similarly, we know the demand function is Q is equal to 2 minus 2P. From here, we can derive the inverse demand function. So which is 2P is equal to 2 minus Q, or P is equal divided both sides by 2. 1 minus 1 half Q. Okay, I'm going to erase this. So total revenue is equal to 1 minus 1 half Q times Q, or is equal to Q minus 1 half Q squared. And marginal revenue differentiate total revenue with respect to quantity. So it's 1 minus Q. Okay, equate this with MC with 0. Imply Q is equal to 1 as well. And plug Q equal to 1 into the inverse demand function. P is equal to 1 minus 1 half times 1. So it's 1 half. Profit is revenue 1 times 1 half minus 0. So it's 1 half. Okay, that's the price, quantity, and the profit in Townsville market. Let's look at B. Now suppose the federal government decides that the price discrimination within Australia will be prohibited. So now Sun has to set the same price in each market, so it's uniform price. Assume demands are such that it pays to sell in all two cities, even under the uniform pricing. So what will the uniform price be? So now we are not allowed to set different prices in different markets. So there's only one price. So total demand comes from cans and townsware, so which is equal to 2 minus P plus 2 minus 2P. So it's 4 minus 3P. So that's Q. So get the inverse demand. Three P is 4 minus Q, or P is equal to 4 over 3 minus 1 over 3 Q. Okay, so total revenue is P times Q, so it's 4 over 3 minus 1 over 3 Q times Q, so it's 4 over 3 Q minus 1 over 3 Q squared. Marginal revenue differentiate total revenue with respect to quantity, which is 4 over 3 minus 2 over 3 Q, so it's equal to marginal cost, which is 0. Okay, this implies that 2 over 3 Q is equal to 4 over 3, or Q is equal to 2 units. So total quantity of output is 2. Okay, and the price would be 4 over 3 minus 1 over 3 times 2, so it's 2 over 3. So that's the price. Quantity and townsware would be 2 minus 2 times 2 over 3, so which is 2 minus 3 over 4, so it is 2 over 3 units. And similarly, cans is equal to 2 minus 2 over 3, so it's equal to 3 over 4. Okay. Alright, that's the quantity, total quantity, price, quantity and townsware, quantity and cans.